So following on from some of the early videos, by us looking at an even number of terms, we've established that it's always going to keep on climbing and climbing and climbing, and it's bounded from above. Therefore, it must have some sort of limit. It must have some sort of limit. Okay, so that works for an even number of terms. So now we need to look at an odd number of terms. So an odd number of terms, we would use this to communicate an odd number of terms. So this here would be us communicating an even number of terms. This is us communicating that is an odd number of terms. So for an odd number of terms, so if you look at this, this is an odd amount here. 1, 2, 3, 4, 5, 6, 7. An odd number of terms. So for you to sum up an odd number of terms, that would be you summing up all the even ones. So sum up to an even amount. So that's this bit here, and then you would add your last term. You would add your last term. Notice that this is S and this is U. So they're two different things. This is us summing up everything. So now we've summed up an even amount, and then because we're looking at a scenario where it's odd. We are looking at a case where it's odd. We are going to be left with one term right at the end here. So we need to add this term here. We need to add this very last one. So for you summing up an odd amount, the odd number of terms, it's really you summing up all the even ones. So pair everything up, add up all the even ones, and then for the very last one, just stick it in there. So this is your U here. Remember, this is S. This is U here. So you can rewrite. Well, you can sum up everything and write it as this thing plus this thing. So hang on. So remember, one of the three conditions was that everything has to head towards the limit. Has to be 0. It has to head towards 0. So if you look at this here, because our sequence is heading towards 0, if you take the limit as n tends to infinity, because the sequence is heading towards 0, the very last term here will be 0, because the limit, because we demand, one of the three conditions was that the limit has to be, the limit of the sequence must head towards 0. So the very last one, this very last one here, as m tends to infinity, then the very last one will be 0, or very, very near 0. But because you're taking the limit, you have to consider it as being 0. So the very last term here, you can consider it as 0. So here, for you summing up an odd amount, just sum up all the even ones, and then you got to add your last amount. Well, the last amount is 0. As you take the limit, as m tends to infinity, the last amount will be 0, because if you have a sequence that's heading towards 0, and then as you head towards infinity, it's going to be 0. It won't be precisely 0, but because you're taking the limit as m tends to infinity, then you've got to consider it as 0. So this thing here will be 0. So you've got an odd amount. So you trying to sum up an odd amount would be you summing up all the even ones first. So sum up an even amount, and then you've got your last term here. Your last term as m tends to infinity is going to be 0. So it's, yeah, you can add, well, it's going to be like 0.000000003, say. This amount here, as you can consider this as being 0 if you take m as m heads towards infinity. So hang on. So hang on. So we can say that the for an odd amount here, because you're adding 0 here. So here, hang on. So for an even amount, it's going to have a limit, some sort of limit. For an odd amount, well, it's going to have some sort of limit, because you can consider it as being this 2m plus 1. You can consider it as 2m and then plus the last amount. The last amount is 0. So if this thing here has a limit of L, then you can think of it as plus 0 if you want. But the point is they're going to head towards they will have the same limit. So if all three conditions have been met, the whole series here will converge to some sort of limit. Okay. I hope you can understand this last part. Because you're going to add a really tiny amount here. This tiny amount, as m tends to infinity, this tiny amount is going to be 0. So it's like you adding 0. So these two are, well, I hope you understand it. Okay.